Okay, so we are going to start here with a example of solving a formula that is a quadratic. So we're solving for v. We want to isolate v and get v by itself. So to do that, I need to move everything away from v. So I'm going to start by multiplying both sides by 2. Okay, so that's going to cancel my 2's, and I'm going to be left with 2k on the left side equals m times v squared. Okay, now to get v by itself, I have got m times v squared, so we need to divide by m. My m's will cancel, and I'm left with 2k over m equals v squared. Now we know when we have a variable squared on one side of the equation that's isolated, it's all by itself, we can take the square root of both sides. And when we do that, remember this is going to be a plus or minus that ends up out front on that other side of the equation. So I'm going to have equals v, but now I'm going to have a little bit more simplifying to do over here. So I'm going to have the square root of 2k in the numerator, and I'm going to have the square root of m in the denominator. But if you remember those rules of algebra, mathematicians don't like to have those radicals or those square roots in the denominator. So we multiply top and bottom by whatever was under the square root, and that way they cancel. So in the numerator, and remember this is still going to be plus minus, in the numerator I'm going to be left with the square root of 2km. We can just put that all together since they're all under the square root. And in the denominator we have the square root of m times the square root of m. Anything that's in a square root that you multiply by itself ends up just being m, because that would turn into the square root of m squared, and that turns into m. So that's why that simplifies. That's why we multiply top and bottom by the square root of m so that it cancels down there. And that's all going to equal my v. So that is my final answer. And that is an example where we're isolating that variable. We were given a formula that's a quadratic, and we're solving for one of those variables.